All right, guys, so we've got 10-2 today. Yesterday we added and subtracted polynomials. Today we're going to multiply monomials. Remember, a monomial is essentially one term. So let's look at this first little example. It says x to the third times x to the fifth. Now, one thing I want you to remember is that there are ones in front of these. And when you do this, you end up getting the answer 1x to the eighth. Of course, you could just put x to the eighth if you wanted to. Let's look at the other one, see if we can see a pattern is what's going on. Now, there are ones in front of these as well, but if I get the answer to this one, I get x to the 11th. Now, what we want to try to see if there is a pattern. The pattern is, if you look at the first one, we got x to the 8th from x to the 3rd times x to the 5th. We got x to the 11th from x to the 7th, x to the 4th. So it looks like what we did is when we multiply terms with exponents, you add the exponents. So let's write that out. When you multiply terms with exponents, you add the exponents. So kind of a template of that would be if I had x to some exponent m times x to some exponent n, I get x to the m plus n. So all you got to do is add the exponents when you're multiplying. So we're going to look at a few examples, see how it goes. So it says use the exponents or the pattern you've discovered to simplify. So we have 3n squared times 4n to the 4th. Now this didn't happen in our examples, but we also have two numbers in front of this. So what I'm going to do first is multiply those numbers together. 3 times 4 is 12. Now I have n, so I'm going to go ahead and put it there, but I have 2 plus 4. 2 plus 4 is 6. So our answer is 12n to the 6th. Now, we can have multiple exponents and variables as well if we look at the next one, but we kind of go in order from first to last. I have two numbers that I can multiply by first. 5 times negative 3 gives me negative 15. Now I'm going to look at my a's. I have a squared times a to the first, so we still multiply our exponents, and we get a to the third. I'm sorry, add your exponents. 2 plus 1 is 3. Now I'm going to look at my b's. I have b to the third times b to the fourth. Well, that's b to the 3 plus 4, which is to the 7th. Let's go to the next one. Now this one's got 3 pieces, so we're going to have to multiply several numbers together. I'm going to go ahead and put my 1 right here, and I'm going to multiply 2 times 1 times negative 3. 2 times 1 is 2. 2 times negative 3 is negative 6. Now we come over here to the a. That's really a to the first times a to the first times a squared. 1 plus 1 is 2. 2 plus 2 is 4, so a to the 4th. Now I'm going to come over to my b's. I have b to the first, b to the first, and b to the 5th. 1 plus 1 is 2. 2 plus 5 gives me b to the 7th. So you can see it's not too bad. Now we're going to get into some fractions on the next one. We have calculators, so we can use those. I have my numbers are 1/2 and 4. 1/2 of 4 is 2. Now here's where it gets a little different. I have x to the 2/3 times x to the 1/3. So that's really x to the 2/3 plus 1/3. Well, since they have the same denominator, we can go ahead and add those together. 2 plus 1 is 3 over 3, which is x to the first. So I have 2x. Now I'm going to go to my y's. I've got y to the first times y to the third. 1 plus 3 gives us 4. So 2x y to the 4th. Now the next one is probably not one you're going to enjoy. It's got some fractions in it, but that's okay because it's multiplication. We don't have to worry about common denominators. So let's look at the numerators first and do what we've been doing. First, I have 20 times 12. It's kind of a big number, but you have calculators. I got 240. I have x squared times x to the third. X to the 2 plus 3 is x to the 5th. I've got y to the first times y to the 5th. 1 plus 5 gives me y to the 6th. There's my numerator. Now I just do the denominator. 3 times 5 is 15. Now that is an answer, but I can simplify because 240 and 15 will cancel, leaving me 16. So my answer is 16 x to the 5th, y to the 6th. So take your time, guys. It's all about multiplication and adding. Pay attention when you're doing them, and it should not be too bad. Let's go to the next page. Now, these are a little more complicated and have some steps that we did yesterday. But let's look at it as individual problems. I have 3x to the 4th y to the 6th times negative 2x squared y plus 8x to the 3rd y squared times x to the 3rd y to the 5th. So let's look at the first two terms there, and let's go ahead and multiply them together. I have 3 and negative 2, that's negative 6. I have x to the 4th, x squared, so that's x to the 4 plus 2, x to the 6th. And I have y to the 6th, y to the 1st, that'll be y to the 7th. Now I'm going to add, let's go to the other one. I have 8 times 1, which gives me 8. X to the 3rd times x to the 3rd gives me x to the 6th. Y squared times y to the 5th gives me y to the 7th. Now, just like yesterday, if the symbols match on the terms, then we can combine them together. Both of my numbers here have x to the 6th, y to the 6th, y to the 7th. So I can do negative 6 plus 8, which gives me 2, x to the 6th, y to the 7th. So you have to remember the stuff we did yesterday. Remember, you can only combine terms if they have the exact same variables and with exponents behind them. So x to the 6th, y to the 7th can only match with x to the 6th, y to the 7th. Now, number 7 is really just a distribution problem. We're going to have to distribute that negative 6t over our parentheses. So first, I have negative 6t times t squared. So there's really a 1 in front of there. So I have negative 6. That's t to the 1st times t squared. So t to the 3rd. Now I have negative 6 times t times 5t. Negative 6 times 5 is negative 30. T to the 1st times t to the 1st is t squared. Now the last one, I have negative 6 times negative 9, which gives me positive 54. And there's only t to the 1st, so t to the 1st. All right. Let's go to number 8. Now we're going to work this like the entire thing times the first term, the entire thing times the second term. So we have p squared q cubed times p to the 1st q to the 1st. Well, p squared times p to the 1st gives me p to the 3rd. Q to the 3rd times q to the 1st gives me q to the 4th. Then I have 1 out here times negative 2 is negative 2. P squared times p squared is p to the 4th. Q cubed times q to the 1st is q to the 4th. Now that's all you can do because I have p to the 3rd, q to the 4th on one term, p to the 4th, q to the 4th on the other. They don't match, so that's my answer. All right, let's go on to number 9. We're almost done. Number 9 is another distribution problem, so just take it in 3 steps and it shouldn't be so bad. The first one, I have negative 3 times 2 gives me negative 6. I have r to the 1st times r squared is r to the 3rd. S to the 1st times s to the 1st is s squared. So there's our first one. Now let's go over to the 12t. Negative 3 times positive 12 is negative 36. R to the 1st times nothing else is just r to the 1st. S to the 1st times no other s's is just s to the 1st, but I also have a t on there to the 1st. So rst, and those variables, guys, can be in any order. It could be tsr, srt, it doesn't matter. Now I'll go to the last one. Negative 3 times negative 7 is positive 21. 7 doesn't have any variables, so the r and s go on the end. So that one's kind of tricky, guys. It throws a variable into the parentheses that is not outside of it as well. So be careful when you multiply things, all the variables have to be there. Now we've got another fraction one here. I know that excites you. I've got 1/3 x to the 1/2. I'm going to have to distribute that twice over my parentheses. 1/3 times 9 is 3. And we have x to the 1/2 times x to the 3/2. So we would add those fractions. We have a common denominator, so I have x to the 4/2, which is x squared. So 3x squared. Now 1/3 times 3 is 1. And I have x to the 1/2 times x to the 1/2. Well, 1/2 plus 1/2 is 1. So I just have x to the 1st. And there's my answer. Now, the last one is a little bit different, guys. It has some setup involved before you can work it, but then it turns out basically to be the exact same problem we have. It says find the perimeter and the area of the shaded region. So first, I want to find the perimeter, P. But to know the perimeter, I have to know all the sides to be able to add them together. But right now, it looks like I don't know this side right here, this side, or this side, but they give me enough information to find it. If this is a rectangle, this side is going to be the same as this side. So this piece is also BC. And the same thing kind of happens here. This 4BC is across from a side that's equal length, so 4BC. Now this outside here is a little bit harder to find. I know the whole thing is 5BC, but if I took off these two pieces, then I'd have what has to be left out here. So 5BC minus BC is 4BC, minus another BC is 3BC. Now I can add all those up and get my perimeter. Well, they're all BC, so they all combine. I have 1 BC, 2, 2 plus 4 is 6, 6 plus 3 is 9, 9 plus 4 is 13, 15, 16, 16 plus 5 gives me 21. That's what the perimeter is. Let's recount those. That's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I got 20 the second time. I may have misadded. So let's go ahead and put 20. Be careful when you count, because if I can miscount, so can you. So now I've got my perimeter. Well, now I have to find area, and it's the area of two different rectangles. Okay, I've got rectangle number 1 and number 2. All we need is length times width. So what I'm going to do is take the length of this rectangle, which is 4BC, and I'm going to multiply it by its height, 3BC. And that'll give me the area of the first one. 4 times 3 is 12. B to the first times B to the first is B squared. C to the first times C to the first is C squared. So that's the perimeter of my one rectangle. The other rectangle has a width of BC times the height of 5BC. Now we can find this area. Well, 1 times 5 is 5. B to the first times B to the first is B squared. C to the first times C to the first is C squared. Now I just need to add these together and I'll have my total area. They have B squared, C squared on both of them. 12 plus 5 is 17. B squared, C squared. And there's our area. That's not a super easy problem, guys, but it does pertain to everything we've done today. So if you have questions on the homework, please let me know. Hope this helps out, and good luck.